Noise. When it is
Noise.
disturbance,
Yeah,
it is called noise.
noise. And there's a pleasant sound like music. It's called sound or notes. We'll see that. Okay. But actually, sound is also a type of wave. Then, by the way, what is wave?
So can we say it as like wavelength, like when we
Structure.
speak based on that, you can decide.
Yeah. Yes. Yes, Niteshri?
So there is wave like in water we get waves. So is it like in that shape in a structure?
Yes. Shape of that. But that shape is a in like if I draw a wave, normally this way we represent our wave, right? Excuse me. So wave is what?
Sound waves.
Yeah, a rhythmic disturbance. See, it's rhythmic disturbance plus and minus. A rhythmic disturbance rhythmic disturbance that what that carries energy. It's moving up and down, though, so that carry energy. That carries energy without carrying matter. That is wave. No, now there can be like two types. One is mechanical, one is electromagnetic. Now, have you heard of both, right? What is electromagnetic? Yes, what is electromagnetic? Okay. Okay. Electromagnetic wave, like those are wave, or in like in terms of matter, there are different ways. Okay, like example, if I give you example, it's light, then radio, then infrared, UV rays. X-ray. These are example of electromagnetic wave. This thing you will study in detail later standard, not now. These are like electromagnetic waves. From that light you already studied. Now in mechanical wave, we have like we have two types of mechanical wave in that. That is transversal and compressional. You already know these things actually. If I draw here, you will understand. Which we are drawing till now, that is transversal. And compressional wave, which is like barcode, if you observe that. It's not exactly barcode, but it's look like barcode. Is my wave going upward? My diagram is going like this. Okay, let it be. Okay. So these are compressional, and this is transversal wave. Now, why they are called so called like it is, see, the waves which are perpendicular to the this line, it's moving perpendicular. See, it's moving away from that, and it's going what, to and forth, means to and fro motion. It's going up and down, or we can say back and forth. That is transversal. Compressional, if you see, like they are straight lines here. See, but what is the difference? They are like thick lines are here, like we can say more density here, less density here. We'll see what they are called. We'll see in detail one by one. Now for that, let's talk about amplitude. What is amplitude? Amplitude, that is height. Simply, if I say this is your amplitude. Now, wherever more density, that is your amplitude.
So am I audible?
Yeah, you are.
Okay.
So amplitude says how high wave rise or fall. How much it's going up and how much it's going down. So in short, amplitude is height of the wave. For this transversal, in longitudinal, or I can say compressional, see how much it compress. Now this part, this portion, let me change color. Okay. This portion is called, what do you see? It's called compression. This portion. And this portion, which you see here, they are called rarefaction. Compression, which has like example, if I give you example, a spring, you know spring, right? So in that, let me show you a picture itself so that you can understand better. One sec. Yeah. Now this one will be better to understand. The stretch part, when you see, this is like when you're stretching a spring, there will be more gap in between. See, that is called rarefaction. That's spelling mistake. It's R-A-R-E. Whatever. This is rarefaction, and it's here which is compressed more. That is called compression. So first compression to second compression is called wavelength. And in this way, if in transversal, one cycle from starting from here to ending here, that is called wavelength. Let me show you a picture for transversal also. Transverse wave. No, this picture is better. Okay. You can see my picture. Is visible to all?
So
Okay. Now see here. So now you draw here. Let me erase this. Now you see this is wavelength. Not just this one, crest to crest, or one cycle. It starts from here and here. That is called one cycle. That is called one wavelength. Or crest to second crest, or throat to second throat. That is also called one wavelength. Wavelength is denoted by lambda. Okay, so let's write all those terms. Wavelength. In short, we can say wavelength is length of wave or length of one cycle or distance between crest to next crest. Or same way, throat to next throat. That is a wavelength. Now time period. Now for knowing time period, we should know first frequency. So let's write frequency first. Okay. Okay. What do you mean by frequency? Generally, we say its frequency is so high. When we are saying like when we are in train, like if we say this train is coming, so like if you are in local train, if we ask like this train frequency or this bus frequency is so much. So what do you mean by that frequency? Like generally, what do you mean by the frequency?
Sir, the number of vibrations per second.
Yes. Number of vibration per second. So at how much, what is its frequency? It's how much it can do. How much vibration it can produce in 1 second. Or how many, if we talk about our train, like how many trains can come in this 1 hour? That is frequency of the train. So number of cycle in 1 second. Cycle means one vibration. Sorry. Or one wave. Number of waves in 1 second. So in frequency, in some book is denoted by V or some book is denoted by F. So as per your book, you can use it. F equals to cycles per second. Cycle doesn't have any unit, so frequency equals to 1 by second. That is called hertz. It was given by Mr. Hertz. And symbol HZ, unit. Unit is hertz or second inverse. Now let's come to time period. Frequency we saw number of cycles in 1 second. So what is time period? Opposite of this one. Can you make a definition of this one? Opposite?
So second by cycle.
Yes, like similar, but here it was number of cycle in 1 second. We want number of cycle in 1 second. We are given particular seconds. So
Maybe
opposite,
1 minute or 1 hour
okay,
minus 1 second.
okay, you're thinking that way, fine. No, let's come back here. Frequency was number of cycles in 1 second. Now time period we can say in 1 second, oh sorry, frequency was number of cycle. Okay, so here how much time it is taking to complete that 1 cycle?
I didn't understand, sir.
Time taken to complete 1 cycle. Here we give particular seconds. Here we are giving particular cycle. 1 cycle. Time taken to complete 1 cycle.
Sir,
Yes.
sir, instead of cycle, what else word we can use? Like
A wave.
if they ask. Okay, sir.
Wave. One oscillation, one wave, whatever it is. So how much time it is taking to complete 1 cycle? That is your time period. Like if I give example of pendulum, you know pendulum, right? Everyone know pendulum?
Yes, sir.
Yes. So for him, what is the cycle? It will go to this point. Let's take it as
Go back and come back to its back point.
exactly. So that is point A. It moved to the point B.
And come back to point 2.
Yes. Come back to your original point. Still, it will go, keep moving forward, but that is not our point. Our point is
That is one time period.
exactly. That is 1 time period. And how much time it is taking to complete that cycle? It is called time period.
Sir, it varies from one to another, right? Sir?
I'm sorry?
It varies from one to another.
Yeah, it depends upon like length also, length of this string, size of the bob, this one, this bob, length of the string, it varies with that. In general, it is 1 second. It will not
Yes.
take so much time. So time taken to complete 1 cycle, that is your time period. So complete 1 cycle, here it is, it starts from O, goes to A and goes to B and return to O. That is your 1 cycle. But it will not stop here, it will keep moving, but that is not our point. That is not our point of discussion. Our point is completing 1 cycle.
Sir, I have a doubt.
Yes.
Sir, while those cycles keep on moving, will they stop at one point or will they keep on moving?
Yeah, obviously it will stop.
Okay, sir, because sometimes when it may continue. So.
It will stop slowly, slowly. It is decreasing. It is depleting its energy. So it will stop some point.
Okay, sir.
And it should stop. Otherwise, there is infinite times, right? Okay, let's make a formula here. So time period. Am I connected? Okay.
Yes, sir, you are.
It got stopped here. That's why. Okay. It is 1 by frequency. Or frequency equals to 1 by time period. Frequency equals to 1 by time period. So
Sir,
if you
if it
remember-
takes more time,
For what?
so you gave frequencies 1 by second the previous time, no, sir. So if it takes more time,
It's okay.
the formula is 1 by second.
Oh, no. I don't mean that. This unit 1 by second is called hertz. Unit 1 by second is called hertz. So frequency is number of cycles in 1 second. If it is more also, then that much hertz. If it is 50 cycles in a second, means that much hertz. 50 hertz. if I write here 50 hertz, means 50 cycles per second. Then if it is more time, that is time period has changed, that means there is a difference in time period. Got it? Let's do, oh yeah, no, before doing some numerical, we need to know speed also. What do you mean by speed?
The velocity.
Speed is velocity. Just a second.
So can we say that velocity is speed, which is nothing but meter per second.
Oh, sorry. Some students are not able to join, so they're asking that. 1 second, let me just share. One second, guys. I'm just sharing them. Okay, by the way, yeah, you were saying what? Speed is velocity?
So can we say that speed is velocity?
Speed is velocity. Then what is velocity then? If I ask you velocity, what is it?
Speed.
Speed is velocity, velocity is speed. That is nice. Like, what to say? I got confused. What you are saying? Speed is velocity, velocity is speed. Then what are they?
Sound.
Yes.
Parts of sound, sir.
Yeah, that's why we are studying sound, right? Why I'm asking this? Wave speed. What is speed? Speed equals to
Distance by time.
Exactly. Speed is distance by time. Okay. So what is the unit of speed?
Sir, meter per second.
Meter per second. That is SI unit. What will be CGS unit then?
Sir?
What will be CGS unit?
Is it meter per second?
No, that is SI unit, correct. What will be CGS unit?
Kilometer per minute.
No. CGS means lower version. I said SI unit means meter per second. CGS, centimeter gram second, which is
Centimeter per millisecond.
no seconds. Centimeter per seconds.
Sir, when meter is changing, then why isn't second changing?
Because it's a CGS. Here, SI means meter, kilogram, seconds. Here, centimeter gram second. That is CGS and that is SI. Okay, yeah, okay, fine. Let's come back to our topic. So our topic is wave speed. So what is wave? Just now we saw a rhythmic disturbance.
Oscillation.
Yeah, oscillation or rhythmic disturbance. So for that, just now we saw wavelength. Wavelength means length of the wave. That is distance. So here speed, let's take as wave speed equals to distance, that is lambda, wavelength. Let me write first words. By time period. Or what is 1 by time period? Just now we saw what is 1 by time period?
A frequency.
Yes. So wavelength into frequency. That is another formula. Let's write in short. Wave speed equals to wavelength by time period or lambda into frequency.
Sir,
Yes,
so what is this WS thing?
that is wave speed. I just wrote in short.
What is?
Wave speed equals to lambda. Wavelength is lambda. It is denoted by lambda. This is denoted by time period, T. This is denoted by F. In some book, there will be notation different. So in your book, whatever notation is that, you can use that. It's just notation, so don't worry about that.
Sir,
The answer and the outcome is the same.
Obviously, yes.
sir, can I ask you something?
Bolo, yes, ask.
Sir, in this wave speed, like what is the symbol like into?
This one, this symbol,
Yeah, sir.
that is lambda.
Okay, sir.
Lambda. That is wavelength. Length,
Sir,
wavelength
and one
symbol
more
is,
thing.
yes.
So what is this wavelength into frequency?
That is wave speed.
Okay,
Another
sir.
formula. Wave speed equals to lambda by time period or lambda into frequency or wavelength into
Okay.
frequency.
Okay.
See, whatever I wrote here, these both things I wrote in short here. Okay. Let's do some numerical with that.
So can you just give me 1 minute, sir?
Yeah, sure. You're writing?
Yeah, sir, I'm noting down.
Okay.
Sir, I'm done writing.
Okay. What about others? Are you all there? Abhinav? You there? Divyesh? Inaya? No answer?
Yes, sir.
Okay. Good. Manideep? You there, Manideep?
Sir?
You there, right? Yeah. Okay, okay. Tanvi?
Yes, sir.
Okay, great. So then let's, after we'll do some numericals, then at last we'll do some quiz on the sound. Let's see. Like some
Yes,
basic,
sir.
some basic questions. I'll search for some basic questions. Then we'll have some good questions also next class. Okay, done. So shall I give question here?
Yes.
So you have formulas, right? So I'm just scrolling it.
Yes,
Okay.
sir. I noted them down.
Okay, this here we go. Question says, if the period of small ripples excuse me, on water is 0.1 second, and their wavelength is 5 centimeter. What is the speed of wave? Try this. It is very, very easy. Excuse me. Just to substitute values in that formulas. Nothing big here.
Sir, 50.
Okay, but did you convert it centimeter to meters? No, no, right?
No.
Try again then. Keep everything in SI units, standard units.
Sir, 5.
Okay. Let's see what other has to say, then I'll say correct or not. Ananya, what's your answer? Still doing? Okay. Inaya, what about you? Okay, somebody typed the answer that. Okay, Manideep, Tanvi, what about your answer? Just substitute values, that's it.
Sir, I don't know which one is right. I sent 2 in the chat.
Yeah, I saw both. Okay. Now let's solve here. So first thing, wave speed. Speed equals to lambda into frequency or lambda divided by frequency.
So why is it named after lambda?
We need to ask Mr. Greek people.
Okay.
Because,
It's named after a scientist, right?
yeah,
Okay.
this Greek people, they like something different, and we just adopted that.
Yes.
Okay. Even you will come to know like so many different like mu, if you know like mu symbol, eta, neta, zeta, chi, very dangerous names. Okay, so this distance, so we need to know first lambda. Lambda equals to 5 centimeter, converted into meter, 5 divided by 100, which is 0.05.
0.5.
Correct.
So my second answer is, oh no, both are wrong.
Both are wrong. Is it? No. Second answer is correct. 0.
So you got 0.05.
No, this is meters. Still, we need to divide by 0.1. It is 0.5 meters per second.
Sir,
Yes.
okay, got it, sir. I
Sir, I
directly
don't know if this method is correct, but I did distance equals to speed into time.
No problem.
Sir,
That is also correct.
I didn't take 5 by 100. I directly took 0.05.
Yeah, that is also right.
Sir, wavelength can be taken as the distance and time can be taken as 0.1 second, right?
Yes.
Yes, sir.
Okay.
So can I do this method in my exam?
Yeah, you can write there like this is distance as a wavelength.
Yes, sir.
Write there wavelength instead of distance.
Okay, sir.
And what's your name?
Sir, I'm Abhinav.
Okay. Okay. So you got this both. Sorry, this answer, one answer only, right? Yeah. We got this answer.
Yes, sir.
Great. Let's go for second question.
Time.
Will you be able to solve? Let's see.
We'll try our 110%.
Yeah, sure, you can try that. It's very easy actually, but you'll see new words. That's why. A wave pulse on a string moves a distance of 8 meters in 0.05 seconds. Find velocity of pulse. B. What would be wavelength of wave on same string frequency is 200 hertz. Okay, let's try this. I want to try this. I want answer from everyone. Somebody wrote something. Yes. No, that is not correct. Distance by time, it is, how much is given? 8. Try again. User, who is that user?
Sir, it's me, Shubhra.
Okay.
Sir, I'm confusing myself. The last message which I have put is the answer of A.
Still not correct. Says 145. This question is very easy, re Baba. Why are you making it so complicated? Velocity of pulse. In
Sir,
short,
can you repeat what is velocity?
yes, just here to use velocity formula. That's it. Find a velocity of pulse. That means distance is given as wavelength here and by time. Distance by time. That's it.
Sir, I did distance by time, but it's giving some unknown answers, sir.
Unknown answer. Okay, what someone has to say, just a second, let me check. Oh, two answers. 16.
Sir, isn't the velocity
So A
8?
has posted the answer. It is 1600, I guess.
Okay. So everyone like gave answer except Divyesh. What about you, Mr. Divyesh? Inaya? Still you are not giving answer? Have you calculated? And Tanvi too. Tanvi? Okay, someone is typing. Tanvi, you there?
So can you just explain the question? I'm not understanding my.
Yeah, that I'll solve. Sure. Okay, internet issue. Fine. Okay, Tanvi, what about your answer? Divyesh, yours? Fast. No? Okay. Then let me solve. First one, it's very, very easy. So velocity, or let's write velocity equals to wavelength by time period. 8 by 0.05.
So you told me to convert it in the previous question.
Yeah, I hope it's already converted. See, meters, already in meters.
Sir, I did 8.
Sir, in the previous one it was.
0.055.
In previous one, it was in centimeters. I asked centimeter, you have to convert into meters.
Sir, can you show this question once?
Yeah. So,
Sir,
Sir,
in the
so I
question,
did 8 by 0.055.
I'm sorry, say again.
Sir, 8 by 0.055.
0.55. How come 0.55?
Sir, in your question, you wrote it as 0.55 seconds.
Yeah, 0.
oh,
Sir, I
I
thought
took
it
it
was
as
5, sir.
0.55.
Oh my God. I'm sorry.
Sir, that's why we got wrong, sir.
Okay.
Sir, so the answer is normal 16.
It's 160. 1 by 2. Yeah. Is it 160?
Sir, it's 16.
800 divided by 5. 60. Yes, it's 160 meters per.
So how did
second.
you get 805?
No, I just multiplied and divide by 100.
Yes, sir, it's 160.
160, right? Okay. What about second part? We need to find frequency, new frequency is given. We need to find wavelength. Wavelength, same formula. V equals to wavelength into frequency. So wavelength equals to speed by frequency. The speed is 160. Divided by frequency is 200. So cancel 4 4s are 4 5s are. So 4 by 5, which is equals to 0.8. 5 8s are 40, means 0.8. What would be the unit here? 0.8 what?
Is the wavelength.
Unit will be meters.
Seconds.
No, meters. Time period is in seconds.
Now, can we also convert it into centimeters and write the answer?
Okay, as you wish. 80 centimeter. Okay. So next class, what we'll study? We'll study about how sound is produced.
Sir, can you also cover the topic which is in our book? How do we hear and how do we
Yeah.
speak?
Yes. How sound is produced and how we are hearing. Or in short, how we are receiving, how we are detecting sound and how sound is produced. Then what is noise, all that, loudness, we'll study that. But for that, we'll have one quiz today.
Yes, sir.
We have 5 minutes, right? Yeah, we have time. Very good. So we can have some quiz. Just let me create a quiz. Mr. Sound. Okay, let's have only 10 questions. Okay, so copy the link on a. Okay, I'll send personal message. Oh, sorry. Yeah. Can you join? Got the link, everyone? Okay, shall I stop
Sir, I
this?
need to again register like that, so it's not letting me to do the game.
How can we start then? Any other way?
Sir, I
Without-
joined.
So it is asking me to register, sir. Yeah, yes, sir.
Just type down your email and it will come.
She tried that day also.
Sir, it will come if you click it the second time.
Try again. See,
Sir, I got it in the first attempt itself.
yeah, no, try that way.
Sir,
Like
stop
they are
registering.
saying, just if you just try, click again, click 2-3 times, it might get login. Check. Let's stop sharing that page, right?